Oh, well, that's a hit to the joy. I just recorded this whole lesson and realized that the mouse didn't click start recording, so I didn't catch any of it. Time to do it again. Hi, guys. How are you doing today? Welcome back to chemistry. Now that we've talked about whatever we talked about, um, alkynes, alkenes, and alkanes, we're going to take this a bit of a step further. So, before, we talked about these kinds of things. You've got carbon connected with carbons, which are connected with hydrogens, and every carbon needs four bonds, so if it only has a couple, it needs an extra one, so it has four, all that jazz. But we didn't really talk about, well, your body's organic, right? That doesn't mean we're just a bunch of carbon and hydrogen. We have to have other stuff, don't we? And yes, we do. And that other stuff is what you call a functional group. So a functional group is something that is not a hydrogen. It's a hotspot of activity on an organic molecule. Remember when I said that we're looking at the areas that have the busiest when we were naming? Functional groups really take care of that. If you've got a bunch of functional groups stuck on one end, that's the busy end. And then what you're going to see in your book is that every time there's supposed to be a functional group somewhere, they're going to use the letter R. R represents group for some reason. You'd think they'd use a G or a FG or something, but thanks, scientists. Very cool. So today is going to be almost completely notes. I apologize in advance. It's a lot of notes, but I'm compensating for that by giving you a very small homework assignment. So stay tuned. Let's talk about the different functional groups you can find. Number one, I'm going to give you the name, an example of it, the name of the example, and then the prefix you'll find on the word. So a halide. The prefix HAL might seem a little familiar to you because if you remember what halogens are, they are these guys in the periodic table. Fluorine, chlorine, bromine, iodine, and very rarely astatine, but we don't talk about astatine. So halides is when you have one of those four pieces, fluorine, chlorine, bromine, or iodine, glued onto the end of a carbon chain. So let's say we had C bond, C bond, F. Two carbons, what do we call that? Ether, right? So we have ether, or I'm sorry, ethane, because it's an alkane. So we have ethane here, and then we have an F glued on. So how are we going to change the name so that somebody reading the name knows there's a fluorine in there? Well, if there's a fluorine, we start the word with fluoro. If there's a chlorine, we start it with chloro. If there's a bromine, we start it with bromo. And if there's an iodine, we call it iodo. So since there's a fluorine, we're going to call this fluoroethane. And that's supposed to be UO and UO. I'm bad at spelling sometimes. So if this was C bond Br, that would be bromoethane. If that was in C-C-I, that would be iodoethane. Okay? Halides. Next up, oh, and I'm going to be moving decently quickly to get through this. So if you need to pause to keep up and copy, feel free to pause at any time. Next one we'll find is an alcohol. We're talking about alcohol in school. So an alcohol is when you have an OH glued onto one of these groups somewhere. You guys probably remember what OH is called based on our lesson about acids and bases. What's OH called? I'm going to leave you to simmer and try to remember. But if you have an OH glued onto the end, that's instantly an alcohol. So let's say we had our three carbons. What's three carbons? Propane, right? So if we have propane plus an alcohol, what do we do to the word? We're going to tack on a dash OL to the end. So this is where you have all these things in your kitchen cabinet that end in all. Lysol, right? It's a bad example. But that's where this comes from. It means there's an OH somewhere in the chemical. So for this one, we would say, okay, busiest end, right? What's busier on the end? This end or this end? This guy's got the functional group, so he's busy. So I'm going to start my carbon numbering there. So that will be carbon 1, carbon 2, and carbon 3. Where is this attached? The 1. So this would be propane dash 1 dash all because it's an alcohol. Yay! All right, so that's alcohols. Let's think about the next one. Ether. So ether is when you have an oxygen squished between two other things. So for this one, we just add the word ether at the end. Easy enough. So I see an oxygen squished between two carbons, so I know that it's going to end in the word ether. If I'm not looking at my oxygen, I've got one carbon over here and one carbon over here. We had a problem like this, I think, last week, where we talked about each single carbon is called a methyl group. And so if I have two different methyl groups, then I can just call that dimethyl. So this one guy would be dimethyl ether. And that's it. Next, we've got aldehyde, which sounds kind of like a Swedish word. An aldehyde is when you have a carbon double bonded to an oxygen at the end of a straight chain. If this double bond was on the middle carbon, it would not be an aldehyde. It matters where it is. So if this guy is attached to the oxygen at the end by a double bond, we're going to end the word in Al. Okay? So we have a straight chain of 3 carbons. That's propane. And if we're supposed to end it in Al, then that just becomes propanol. And we're good. And yes, these are pronounced the same. Propanol, propanol. I'm going to say propanol just to make it easier to distinguish. But after aldehydes, we've got something similar, which is called a ketone. So a ketone is kind of the same idea, but instead of that little oxygen being double bonded on the last carbon at the end, this one's going to be somewhere in the middle. So these words, ketone, will end in "-one". You'll notice these words, aldehyde, al, ether, ether, ketone, "-one, they kind of mirror each other. So now I'll have to do the same thing. What's my carbon chain? 3. What's that? Propane. What do I end the word propane in? "-one, because I got this double bonded oxygen, so it's propanone. And that's that. After ketone, I've got my friend carboxylic acid. Nobody likes carboxylic acid. And whenever you see a carbon who's got two friends, a double bonded oxygen, and an OH, which if you didn't remember from last time, was a hydroxide. If you got a carbon double bonded with an oxygen and single bonded with a hydroxide, you're going to add the ending oic acid. So how many carbons do I have? 3. Propane. So propane, adding the ending oic acid, would be propanoic acid. And that's it. Next up, we've got ester. So if we've got an ester, we're looking for a carbon who's double bonded with an oxygen, single bonded with an oxygen, and bonded to something else. It doesn't really matter what. So double bond with oxygen, single bond with oxygen, and then something else. So if you see this, you're going to be ending your word in O8. So we've got 4 carbons here, but if you'll remember, we name things based on the longest chain. What's the longest chain we have here? It's these 3 carbons. So what is a 3 carbon chain called? Propane. So the main bulk of our molecule is going to be propane O8 because of this guy. Propane O8. Now, if we use up all this, what are we left with? A lonely little carbon. What's a lonely little carbon called? A methyl group. So this will just be methyl propane noate. That's where we get the name. We're almost done. Next up, we've got an amine, amine. And these guys are going to be a nitrogen stuck between stuff. Okay? If you see a nitrogen stuck between stuff, it's going to end in the word amine. And I picked this one because of the hilariously awkward name, methylethylamine. Try to say that, it's actually kind of fun. What gives you methylethylamine is this nitrogen is splitting up one carbon and two carbons. What's the one carbon called? Methyl. What's the two carbons called? Ethyl. So you've got methyl, ethyl, amine, ending in amine. It wouldn't be methylamine ethyl because this is supposed to be at the end. So you couldn't say methyl amine ethyl or amine methyl ethyl. It's got to be in that order. Last but not least, we've got the amide. So the amide happens when you've got a carbon stuck with a nitrogen and double bonded with an oxygen with something else over here. That's why I'm highlighting the bonds on these, because it's got to include something else. So carbon double bonded with an oxygen, single bonded with a nitrogen, and then bonded with something else. This specific one has a carbon chain of 3 length, which means it's propane. And this buddy means we're going to call it amide at the end. So I have propane, amide, propanamide. And there we go. So tomorrow and next week, we're really going to hit this harder on the specifics. But today I wanted to give you the loose meaning of why do we call these things what they call them. It's so scientists can look at a name and know what pieces there are. They can look at this name and say, okay, propane, I got 3 carbons. Amide, I got that little functional group attached somewhere. And if they looked at the name, they could draw this. That's the goal. So, your homework today is going to be to look in your house, okay? And find 2 things that in the ingredient list use one of these, okay? So look for something on the ingredient list that uses maybe one of these words like methyl, propane, butane, butyl, any of those words. Something that uses amine, amide, O8, oic acid, one, al at the end, all at the end. You can't use Lysol. Fluorochlorobromo iodo, any of these things. Look for something I'd recommend in your under your kitchen sink, maybe in your medicine cabinet. Find 2 things that used one of those words or prefixes, and send me the 2 pictures of the 2 things. And I'll be accounting that for your homework grade. I figured you spent a lot of time writing today. I'm not going to make you do Google Classroom work. We can save that for later. But with that, um, I hope you guys think this is at least remotely cool. Um, and I hope you have a fabulous Thursday. I'll see you tomorrow.